as well as Professor Nilanjan Baborta in some of the sessions. So let us proceed with the very introductory portion of computer network. What is this course all about? Why do we need to study this? Which textbook I will primarily be following, so on and so forth. So, why do we need this query? Why do we need this course? This does not require any answer, I believe. All of us are communicating. All of us are communicating. All of you are using WhatsApp, Signal, Telegram, emails, and face-to-face communication, uh, then phone communication, etc., etc. If you look into this slide, some of the networks, example networks we have used, communication network, transportation, social, biological, utilities. And believe me, this subject is primarily common sense put into technological parlance. So let me check some of the queries. Okay, fine. No queries as such. Yeah. So that is it. That we will primarily be interested in this course in computer network part. Now, when I talk about communication, there are a few entities related to communication. What are those? First and foremost, the sender, right? If there is a message, then that message needs to be sent across. So the first entity we can think of is a sender of the message. What if there is a sender, there must be receiver, the entity which receives the message. So sender, receiver, receiver is our second entity, we can put it that way. Third, what does a sender send and the receiver receives? A message. So the third entity is message. What is the fourth entity? Fourth entity is medium or channel by virtue of which the message gets transmitted. I hope all of us understand that channels can be either wireless or wired channel, and when a message is traveling from say Kolkata to California, I hope we understand that some portion of it will be traveling via wired medium and the other portion of it will be traveling via wireless medium. So our fourth entity is channel or medium. What is the fifth entity? We had four of them already: sender, receiver. Yeah, so there is one query, sir. Can you repeat the entity once again? That's what I'm doing. We have only talked about four entities till now. First one was sender. Second one was receiver. Third one was message. Fourth one we have talked about till now is medium or channel, by virtue of which the message gets transmitted. What is the fifth entity in our communication? Fifth entity is something known as protocol. Protocol. What is a protocol? We will get to know. Yeah, someone says set of rules already. So protocol is nothing but set of rules. Examples, we will talk about a lot of them: HTTP, TCP, UDP, don't worry about it. But for a layman's perspective, if someone tells you hi, if someone tells you hi, you are not supposed to tell him or her bye. What are you supposed to tell? Hello, maybe, or how do you do? So that's something protocol, set of rules, which will basically govern the way the message communication happens from sender to the receiver. So what are the five entities? Message, sender, receiver, medium or channel, and protocol, which is nothing but the set of rules which will govern the communication of the message from sender to the receiver. So these five taken together is basically our data communication. Now, the books which I'll be following mainly are Data Communication and Networking by Farhausen, Data Communication and Networking by Farhausen, and Computer Networks by Tannenbaum. Computer Networks by Tannenbaum. Uh, these slide sets, you can always take those from me. I'll share these in your group, in your channel rather. So these are majorly from the Tannenbaum's book. Okay. These are majorly from the Farhausen's book. Now, any book you can refer, either Tannenbaum or Farhausen or William Stallings, that's completely up to you. But my concern is that what are we going to learn in this course? What are we going to learn in this course? Let us understand it from a layman's perspective. Try to understand it from a layman's perspective. Someone opens up the browser. It can be Firefox, it can be Chrome, it can be Internet Explorer, I understand, but majority of the people these days, they use Internet Explorer to download Chrome and then they start using Chrome. Anyways, so with due regards to Internet Explorer, when I open up Chrome and in the address bar, I type out the URL www.google.com, okay, www.google.com, and for example, I am doing it for the first time in my computer. I'm doing it for the first time in my computer. So I type out www.google.com, and what happens? Within a few seconds, I get to see the homepage, so-called homepage of Google, right? With that Google logo and the search bar, so on and so forth. We are going to learn throughout this course, not only me, but all other 3 faculty members. They are going to teach you what happens in the background when someone types www.google.com in the address bar of a browser. What happens in the background to fetch the home page on your browser in few seconds, right? This single question we are going to learn for next 4 months. That what happens in the background, how it happens, so that we get to have the so-called, some people are answering something, DNS comes into play, okay? So it's like, as of now, the knowledge we have is basically, I remember one story that there were few gentlemen whose eyes were blackened in the sense with a black piece of cloth, it was tightened. And 5, 6 of them, or maybe even more, say 10, 12 of them, then they were sent near an elephant, okay? And they were instructed, now feel the elephant. So someone touched his tusk, someone touched his trunk, someone touched his tail, someone touched his, the legs, the pillar type legs, someone touched his ears, and then they described it as per their own knowledge. Someone said it's like pillar, someone said no, it's very small. Who touched the tail, who said it's very small. Someone said it's like a sword, a bit long, a bit thick, who touched the tusk, so on and so forth. But when you club them together, that makes the elephant, right? So we understand that. So the knowledge we have as of now, majority of us, someone says DNS comes into play, someone has already written, it's all about IP address and all. Good that we have things which we all know, because please understand, till today, before this class maybe, or before this course maybe, all of you are network users already, right? You are attending online lectures, you are writing so-called online exams, so you know how to use technology, you know how to use communication technology, Facebook, Twitter, Instagram, WhatsApp, Signal, Telegram, you know everything, emails for a change. But at the same time, from today onwards, start asking yourself that how it happens, number one. Number two, why it happens this way and not a different way. And number three, is there any way we can improve it? Is there any way we can think of improving it? So how it happens? Because please understand, any Tom, Dick, Harry on the road, they know that what happens when I send a WhatsApp message. They will say, it gets delivered. जाके पार्टी जीता के चलो गया, जिसको भेजा है उसको मिल गया. So that everyone knows. But at the same time, you guys should be computer science engineers. You guys should be in a position to explain that how it happens, what happens in the background, and why it happens that way and not in a different way. And you need to analyze yourself that is there any way you can improve it or you can think of improving it. Let me again look into the question panel. Okay, there are people answering, yeah, they are sticking to the previous discussion, DNS lookup to find IP address, etc., etc. Great going. Okay, we'll learn throughout this course that what happens in the background when you type out google.com in the address bar, and you get to know that, oh, okay, the Google homepage looks like this, right? So having said that, we understood the entities of communication. Now let us go to something known as topology. What is this topology all about? Topology is nothing but how the systems are physically connected. How the systems, network, right? Network is nothing but communicating. It's like saying more a person is connected, not connected by number of friends, but connected by a number of real friends maybe. So more your network is, more your net worth is. That is, there is a nice saying about it. When you go into industry or your professional career, you get to understand this more, that more a person is net worth, more the net worth of that person. Anyway, so in our case, physical connectivity is nothing but topology, okay? So it's like there are basic topologies, three of them: bus, ring, and star. I'm not looking into the queries right now. I'll cover a little bit of portions, then I will take the queries one after the other, if you allow me to do so. So there are three basic topologies, mainly bus, ring, and star. And there are some derived topologies which we are going to come next. What is this bus topology? So there are, for example, there are two types you can think of. Let us start with the easier one. Computer A to computer B is connected via cable, B to C, C to D, D to E, E to F. So everything is connected via cable. So obviously you understand that when computer B is taking connection from computer A, it's an incoming connection. For outgoing connection, there has to be another port. Is not it so? Or else you can think of, like this picture shows, there is a single drop line, bus drop line, and from that drop line, the nodes are connected. Okay, so as you see, series of computers or systems, switches or nodes connected by a link in a line. The end computers, if you think X to Y to Z, all the end computers will have two links, except the end computers, everyone in the middle will have two links, one to the left, another to the right. But the leftmost one and the rightmost one will have one link connected, if we put it that way. This is what ring is. The last two ends of the bus, you connect them, that makes you a ring. As simple as that. In a closed loop, computers or systems connected in a closed loop, that's ring. And what is star? There is a central point, there is a central hub in which all the nodes are connected. And any central system, looking at this picture, we understand that if the central hub fails, the whole thing goes wrong. The network is dead. If you go into derived topologies, mainly there are two types, tree and mesh. I take the mesh first. For example, there are 5 nodes, A, B, C, D, E. So An ideal mesh topology would be that every single node is directly connected with a link via a link is directly connected with every other node. So these five nodes you can think of as, say, five cities of India: New Delhi, Kolkata, Chennai, Mumbai, and maybe Bengaluru. So basically, I am saying that from Kolkata, there will be direct flights connecting New Delhi, Mumbai, Chennai, and Bengaluru, and similarly for other four cities. So that is basically an ideal mesh topology we are talking of. Left side picture, it's tree, and this you have seen already. The tree picture, many of the households these days, they have this DTH connection, direct to home connection. I'm not talking about those, but if you go back 5 years, there was this cable connection, right? In those cable connection, it was, I hope you have seen it, right? Some black boxes hanging from the lamppost, and the cable guy from one black box to the other, he is pulling a string, pulling a wire, connecting it here. From that black box hanging, he is again connecting it to five homes, five houses, and one cable, he is taking it to the next black box hanging in, say, around 100-meter away in another lamppost. So basically, this is the tree structure. From one node A, you have connected B and E. B, C and D connected. E is connected to F and G. And this structure, it might strike your mind, sir, we have studied this already in our data structure algorithm course. Yes, you are correct. You are absolutely correct. We will talk about it in some day once we learn this IP address and all, many of you already knowing it, that our university campus has more than 1200 computers, more than 1200 computers for student usage. And we have received only 5 IP addresses. We have received only 5 IP addresses from our internet service provider, Vodafone. I hope all of you know that IM Group, we have a 4 Gbps, 1:1 non-shared lease line connectivity. 1:1 means your upload and download speeds are same, and non-shared lease line means this is a dedicated lease line for our group given by Vodafone. Our university has only 5 IP addresses, and we have 1200 computers for student usage. Okay. Now, with that, how do we distribute internet connectivity to all 1200 computers using only 5 IP addresses? This is what we are going to discuss in one of the sessions after we gather some amount of introductory basic knowledge about computer networks. We will do that, don't worry. Why so many topologies? So why so many departments in the government? So it's something like that. So each has its own advantages, disadvantages. Bus require fewer cables in comparison to star. If it can be say the connection between A and B is cut, so the communication between A and B is off. B, C, D, they still remain connected. Okay. Preferred for LAN, yes, but nowadays it's more of star in which people are relying, star and mainly tree in which people are relying. Ring, there are 2 pictures actually. Left one is showing 2 rings completely. One is inner ring and another is outer ring. So inner ring remains unused except during failure, and outer ring is mainly used for data. So you can visualize it as there is only one ring which is working fine to take data. Say there are from this node, say from node number 1 to node number 3, we are sending across data, or node 1 to node 4, maybe in the anti-clockwise direction we are sending data. So it will travel from 1 to 2, 2 to 3, 3 to 4, right? Plain and simple. Now, what happens? Why ring is better compared to a bus structure in majority of the cases? If there is a failed station, look at picture B on the right hand side. That station has failed. Failed, it can be because of communication failure from either side, or the node has gone down, it has gone dead. What happens? The station adjacent to the failure loops back the bad news, and then comes your inner ring in use. So the bad news gets traveled to all other nodes through the inner loop that, okay, boss, don't send any further data to this station till it comes back up. Okay, that's the advantage of ring. It takes the bad news to all other nodes via the inner ring. Star, we already discussed. If the hub fails, it's gone. Requires more cable for every node you require those. Star is easier to design, and that is the reason all those big organizations, they use star topology, and that too in an elongated format. That is your tree topology, which is a derived topology. Yeah, we talked about it, cable TV, etc. Those are basically the basic structure is star. So tree and mesh, obviously you understand, you try to directly connect to all other nodes, automatically your budget will be increased. You will require many more number of cables to connect it. We are only considering 5. You make that 5 to 50, it increases exponentially. So mesh is not at all cost effective. Tree, yes, that is the one which is used majorly. Now, this is important. This is very, very important. Look into the left structure, left picture. Say I want to send data from node 1 to node 4. I repeat, I want to send data from node 1 to node 4. So how will the data travel? The data will travel from node 1 to central node, and then central node to node 4. That is how star operates. It is through the central hub. Any data from any node is sent to the central hub. Central hub will forward required to send it across. Okay. So 1 to 4, the data will travel like 1 to central node to 4. That is how your arrowheads are showing. Arrowheads are nothing but the direction of data flow. So leftmost picture, left-hand picture looks like a star physically, and logically it is star operation as well. Logically, why? Because the communication is happening through central hub directly. 1 to central hub to 4. That is how star operates. Come to the right hand side. This is important. Understand it carefully. By look-wise, leftmost picture, forget about the arrowheads. Look-wise, there is a central hub. There are 4 nodes. If I don't consider the arrowheads, left and right pictures are looking same. If I do not consider the arrowheads, left and right pictures are looking same. So physically, the right picture is also looking like a star topology. But logically, now let us analyze. I want to send data from node 1 to node 4 again. See the arrowheads. Node 1 to node 2. Node 2 to node 3. Node 3 to node 4. So basically the central hub is nothing but a dummy. The central hub is nothing but a dummy. The communication is happening 1 to 2, 2 to 3, 3 to 4. What type of communication is that? That is ring topology. So your arrowheads are most important and vital information about the structure of a particular network. Rightmost picture, right-hand picture, though it looks like star, but it actually is ring topology. Clear? This is known, I believe. Unicast 1:1. I'm talking to one of your friends that's unicast. Say there are 100 of you, and I am talking to 30 of them. That is multicast. Few in the network. And what is broadcast? There are 100 of you. I am talking to all 100. So unicast 1:1. Multicast 1:x out of n is greater than x, and broadcast 1:n. N is the total size of the nodes or total number of nodes in the network. That's what it is. Message frame packet, we will consider it as we move deeper down the layers, same meaning given with the headers, the nomenclature changes. But as of now, let us consider it on the message. Bitrate, baud rate, and bandwidth. Bitrate, you all know, number of bits serviced, transmitted per second. What is baud? Although this is a discussion related to physical layer, sir, what is physical layer? I'll come to that, don't worry. But let me explain it with a easily understandable example. Say there is a car, there is a moving car, which is driver driven. It is not a Tesla specific model. It is a driver driven car. Okay. So when I say it's a moving car, we understand a driver is driving it, sitting inside the car. Now, it's a sedan, for example. So how many people can it accommodate? Minimum, the moving car I am saying, minimum it will have one person. Why? The driver himself or herself. It can have two persons. It can have three. It can have four. It can have five. Is not it so? From sedan, I make it a, say, SUV. The five can go up to eight. But minimum remains same, one, the driver. From sedan, from SUV, I make it a traveler. Now that 8 now becomes 15. Minimum remains same, 1, because it's a moving car and the driver is driving it. Clear enough? Great. Now what is baud? B-A-U-D, baud. In your textbook, you will find the definition as one signal element is a baud. Now this signal is not your signal app, signal, telegram, WhatsApp, not that. This signal is communication signal we are talking of, electromagnetic signal. We will talk about it. You cannot take www.google.com, you cannot take G of Google and throw it to California. You cannot do it. It has to go via electromagnetic signals. The message can only go via electromagnetic signals because that is what only which can travel. Now, baud, your bookish definition is one signal element is baud. Now, one baud can be represented by single bit. Analogy, one moving car has to have one minimum person inside it, the driver driving it. So one baud is your car, the moving car, signal element. One baud can be represented by single bit. In that case, I hope you understand baud rate and bit rate will be same. One baud equal to one bit, 5 bauds are transmitted per second. One baud equal to one bit. If we do it that way, that means 5 bits are transmitted per second. One baud can be represented by 2 bits also. One car, moving car can have 2 persons, driver and another person. So when I have one baud equal to 2 bits, 5 bauds per second is nothing but 10 bits per second. So that's the relationship between baud and bit. Baud is a signal element which has to be represented by X number of bits. X number of bits. Signal element has to be represented by X number of bits. X minimum has to be 1. You have to have a driver inside a moving car if it is not an automatic car. Okay. So one signal element must be represented minimum by 1 bits. Maximum it can go up to a logical level. We will learn that in detail in physical layer. So that's the relationship between baud and bit. Moving car and the number of persons sitting inside it. Minimum 1. So one baud minimum can be represented by 1 bit. Maximum it can go up. bandwidth, you know this already. C equals F lambda. You learned it in 7th standard, I believe. C is your speed of light. Lambda is your wavelength and F is your frequency. So bandwidth is your highest frequency negated the lowest frequency. That range is your bandwidth. These things are, you know it better than me. Arrival rate, number of bits arriving, departure rate, number of bits leaving, obviously per unit time, propagation delay, time from X to Y. Now X to Y, when I say this, okay, let us directly go to that airport example. We'll explain it better. This is known first generation network, few hundreds of Mbps, copper based. You had ARPANET, Ethernet. Okay, I think many of you know this already. Still, let me reiterate. This whole thing, computer network, the whole thing started off by Department of Defense of US government. So basically, this improvement, what we are seeing today, and even before that, if you consider, it was our Acharya Jagadish Chandra Bosu who eventually thought of and started this, which was taken up by Marconi, published, he got name and fame, but we all know in our, and obviously the world community has now given that, okay, yes, along with Marconi, it was Acharya Jagadish Chandra Bose, but at our heart, we know that it was Jagadish Bose who started this all for us, and he was the pioneer for which now we are so well connected that we are communicating over web. But after that, in a bigger manner, this whole computer network thing was started by Department of Defense, okay, in that ARPANET project. It was again this military requirement which eventually became a research problem, and then the whole thing started evolving. So it was a military requirement that we need to communicate, otherwise the cost incurred is becoming too high and it is becoming very less reliable. Cost incurred high, reliability less, that's a very loss situation. I mean, in yesteryears, people used to fly pigeons, right? That was also communication. Get the letter tangled with its small legs and throw it across, and keeping in mind that it may eventually go to the right place. You never know that what happens in the mind of the pigeon and it travels to some other place, or maybe because of wind direction, things could have gone wrong. That was communication as well. So it was, but that was very less reliable. So this is it. It started off as a military requirement, became a research proposition later on. Things started getting evolved, right? So 1G, that was first generation. Then second generation, fiber came in, copper replacement. You are increasing in speed. Third generation, fiber with wavelength division multiplexing, WDM. So what is that? Don't worry, you have whole physical layer to be dealt with. And then you are having your 4G, 5G. 4G implementation should have been such that when you are starting to walk at the top of the ground, say from Mahatma Gandhi Road, above the ground level, on the ground, that is above the metro channel, and then you are going down the escalator or maybe stairs, you are talking to someone, you go deep down to the ticket counter, purchase the ticket, wait for the metro to arrive. Metro arrives, you get inside the metro, doors close, the metro gets into tunnel. Then it goes beneath the tunnel, etc. Now we are getting this east-west metro connected. It will travel beneath the river Ganges. So 4G implementation ideally should have been starting someone at the ground level, say somewhere in Mahatma Gandhi Road or Central, above the ground level, coming deep down to the tunnel, going down through the river Ganges, then again going up somewhere in Howrah Maidan metro station above ground level. Someone keeping on talking in the phone, it remains uninterrupted communication. Did it happen that way? Implementation? You know the answer better than me. So that should have been the 4G implementation. In 4G, what we have been given is basically a marketing gimmick, a little bit of increase in your speed, done. Once this single company has come into play, then we have understood the previous companies, they have looted us in the name of data charge. Anyway, we have started understanding that. But nevertheless, 4G implementation, ideally this should have happened. Whether it has happened or not, you know better than me. Network classifications according to size, these are all your lower class things you already know. LAN stands for local area network within a single building or couple of buildings. MAN, metropolitan area network. WAN, wide area network, right? Couple of cities, they connect WAN. Now, what is this intranet and internet, small I? Intranet is within the network. Intra-college quiz competition within the college. Inter-college quiz competition taking multiple colleges. So similarly, internet, small I, is network of networks. And what is your internet, capital I, triple W, World Wide Web? That is the spider-like web. The spider-like web which is engulfing the whole world. That is your internet, capital I, which is nothing but a conglomeration of all the wide area networks, a conglomeration of all the internetworks, of all possible connectivities, public connectivities. That is most important. Internet, capital I, is a public network. Anyone can use it. According to physical medium, we already talked about it in the beginning, either wireless or wired network. The upper one, types of service, voice or data. This is interesting. I give you two examples. Voice network of Easter years, previous years, the cling landline phone. You dial my number. Oh, that will seldom happen. But nevertheless, for example, you dial my number and it rings. At my end, I pick it up. I say hello. You get to hear my voice. That call is now dedicated between you and me. Okay. It's a channel. I hope you understand that channel is created, dedicated path. Is it good? Yes, for two of us, it is good. It's a dedicated channel. We two are speaking. No one is supposed to jump in. Yeah. There were cases. Yes, there were cases. There were cross connections. That was a technical fault at the exchange level. Let us not talk about it. Let us see the normal process. It's a dedicated channel. Now, what happens? You ask me some questions. I take some time to process the questions, then process the answer, then I speak. So, if we are connected for 5 minutes, for example, out of those 5 minutes, believe me, we will speak. If we two are normal people, that's most important. Two normal people, they will never utilize, they used to never utilize 100% of the channel time. Sir, বুঝলাম না কি বললেন? 5 minutes we were connected. You asking something, I answering, I am asking something, you answering, we are sharing information, opinion. The whole communication taken together, it will not add up to 5 minutes. It will be adding up to say 3.5 minutes. Rest 1.5 minutes or 1 minute will be blank period. We were thinking, we were processing, it was getting transmitted, so on and so forth. So this, out of a 5-minute session, even if 30 seconds are wasted, that's a 10% waste of the channel time. Voice network. In one call, you are wasting 10% channel time. You consider millions of number of calls per day globally. It's not million, it's billion. If there were billions of calls per day globally, and you don't utilize 10% of those channel time, I hope you understand the amount of wastage we are talking of, amount of bandwidth wastage, amount of channel time wastage. So, what is the solution? Solution is data network. Data network, what is the example? It's like Red Road. You have major arterial road in Newtown, or you have Red Road in central Kolkata. The road is there. Anyone can take the cart through. if there is space available. If there is no space available, the whole road is jammed with cars, vehicles, you cannot take your vehicle through. Otherwise, the road is kept open 24 bar 7. You can take your car through whenever you feel like. That's your internet. The World Wide Web is the public network. It's open. If you want to transmit data through it, transmit it. Absolutely no problem. Pay the fees, do the honors. Plain and simple. Uh, we will go into this airport example next class. But just to give you one, don't worry, these things we will be talking about. This is what organization of air travel looks like, right? When you are traveling from Kolkata to Mumbai, maybe you purchase ticket, you go to the airport, you check in your baggage, you load yourself into the aircraft, runway takeoff happens, it's getting routed by the air traffic controller, and if it has taken off, it is getting landed at Mumbai airport. I loaded myself in the aircraft. I'm getting unloaded. I'm coming out of the aircraft. I take the baggage claim, and something is written. Complain if there is any complaint. And human psychology is everything goes correct. We don't give any feedback. But something goes wrong. ব্যাগের হাতলটার একটা সাইডে একটা স্ক্রু খুলে গেছে, গিয়ে যে অফিসার দাঁড়িয়ে থাকবে ওখানে তার উপর চিৎকার চেঁচামেচি চোটপাট করে দেবো, আমার সুটকেস ভেঙেছে। Anyway, this is how this whole organization of air travel looks like, right? 850 kilometers, 800 kilometers per hour traveling aircraft, say 2 hours here to Mumbai. This is how it happens. Now we will segregate it by the type of work they are doing. So this picture and the next picture are same, but we have just grouped the similar type of work, but the whole thing remains same. So this basically is, and then at the departing airport and arriving airport, we have just grouped them, is the same first picture being grouped in different manner. This will basically give birth to our further discussion. For computer network, there are two models in place. One is ISO's 7-layer OSI model, Open System Interconnect model, APSTNDP from top to bottom, application, presentation, session, transport network, data link, physical. And then we have this internet protocol stack. Instead of 7 layers, there are 5 of them: application, transport network, data link, physical. It's not actually 5. First layer application is taking care of the responsibility of the first 3 layers. That is application, presentation, session. Don't worry, we will discuss this in next class. But just for your reference, I'll be dealing with in this course application and transport layer, part of network layer also. Sumit Anand sir will be dealing with network layer and data link layer mainly, and Shubhalakshmi ma'am and Nilanjan sir will be dealing with the physical layer. So by the end of this course, I hope all of us will be in a position that what happens in the background when you type out www.google.com and you get to see the web page, copy of the home page in few seconds. So there are few queries, right? One has talked about virtual private network. Don't worry, sir, we will talk about them. Mainly, thank yous. There was one query about bitrate, baud rate. Someone is saying subnetting is used to distribute. I believe I have talked about bitrate, baud rate in detail. Yes, I'll be sharing this PPT to Telegram channel. What else? There are some queries which will be dealt with in higher layers. Don't worry. Any tree topology, you have read it in your data structure course. They are basically part of your tree topology in computer network. Any tree topology you have studied in data structure course, they are tree topology in computer network. Okay. Someone is asking, there is no difference between ring and mesh. No. They are entirely different. Mesh is From A, say there are 5 nodes, A, B, C, D, E. From A, there will be direct communication. If it's a complete mesh topology, we are saying there are incompletes also, but it's in complete mesh topology. A to B, A to C, A to D, A to E. Direct communication links will be there. Similarly, B to C, B to D, B to E, and B to A, obviously. So basically, every node is directly connected to all other nodes. That's your complete or ideal mesh topology. Ring is completely different. Ring is A to B, B to C, C to D, D to E. Those are communicated in a ring structure, right? So if you want to send from A to D, it has to be A to B, B to C, C to D. But in case of mesh topology, A and D are directly connected. So directly it will come from A to D, right? Someone is saying subnetting is used to distribute. We will learn about it. Then what is WAN? We discussed. Okay. Is Internet Protocol Stack similar to TCP/IP? Yes, that's TCP/IP protocol stack is Internet Protocol Stack. You are correct. Someone is asking, sir, why do we sometimes not get connected to mobile network? What is the problem? The problem is you had hunger of 2 biscuits and you are trying to eat 5 full plate biryanis of Aminia. That's the problem. We will talk about that in physical layer in time division multiplexing and frequency division multiplexing. The number of simultaneous users it can support and the number of subscribers you have, the ISP have. So basically it's, if it is 100 which can use the channel, they have subscribed to 10,000 minimum. Keeping in mind that not all 10,000 will try to connect simultaneously. More than 100 trying to connect simultaneously, there will be call drops. That is what is happening. দুটো বিস্কুটের খিদে ছিল, 5টা বিরিয়ানি খাওয়ার চেষ্টা করেছি. Someone is asking for attendance. Okay, the attendance is already there. Those of you who have registered and attended this is an automatic attendance thing. And more importantly, I don't think you had attended, or I had very few sessions with you in previous semester. I don't take attendance in my class, plain and simple. Those who want to attend, they are welcome to attend. Those who don't want to attend, they are most welcome not to attend. So those who don't attend, it's their loss, not mine. I don't take attendance in my class ever, because my class is like, always I take classes either in B3 seminar hall physically or in AV hall. So I don't waste time taking attendance. Okay. Okay, then it's 11:22. Join your next session. Thank you so much. We will meet every week on Wednesday, second period. Thank you so much. Bye-bye.